Welcome to aminacademy.com. In mathematics of quantum mechanics, let us discuss about Euler's formula and the polar form. Look at this. Euler's formula we can write look at this e power I theta equal cos theta plus I sin theta. Consider the complex number z equal a plus bi. Now modulus of z modulus of z is equal modulus of z modulus of z, that is a plus bi. Now from this we can deduce a equal modulus of z cos theta and b equal modulus of z sin theta, where theta equal tan inverse b by a, or theta equal sin inverse b by modulus z, and cos inverse theta equal cos inverse a by modulus z. These are the result. Now consider z a plus bi, a complex number. Now we can write this as a is already modulus of z cos theta plus b and modulus of z I sin theta. Now modulus of z take out common, cos theta plus I sin theta. By Euler's formula, we can say z equal modulus z cos theta plus I sin theta. By Euler's formula, I can write e power I theta. Look at this example. Suppose z equal phi minus phi I. How we can find in Euler's form? First, modulus of z square root of phi square plus minus phi square, which is equal square root of 50. Therefore, this modulus is equal. Then theta equal tan inverse tan inverse 5 over minus 5, which is equal tan inverse of minus 1. Of course, it is 3 pi by 4 or 7 pi by 4. Or these are the tan inverse of minus 1 values in terms of pi. Therefore, here then we can see 5 minus 5i is equal root of 50 e power I 7 pi by 4. Next one, complex conjugate. Complex conjugate of a complex number in polar form. You are finding complex conjugate in polar form of a complex number. Look at here, e power I theta 1, which means it's a complex conjugate, equal cos theta plus I sin theta conjugate. Conjugate of these things is cos theta minus I sin theta. It's a conjugate of cos theta plus I sin theta is cos theta minus I sin theta, which is cos theta can be written as cos of minus theta plus I sin of minus theta, because sin of minus theta is minus sin theta. So this minus minus become plus. Cos of minus theta is equal to cos theta. Since now which is equal e power minus I theta. Therefore we can write the result e power I theta conjugate is equal e power minus I theta. Therefore, from this result you can find conjugate of the complex number. Now let us write the summary of the results. First one, write the summary of the result. Look at here, first one, e power I theta into e power I theta, which is I phi, another angle. We can write this is equal e power I theta plus phi, another angle, which gives z into w, product of the complex number, which is equal modulus of z e power I theta into modulus of z modulus of w, second complex w, which is equal modulus of z modulus of W e power I of theta plus phi. Second result, e power I theta whole power n equal e power I n theta or any number, and n could be a complex. N could be a complex number. Any for any number, that is n could be a complex. Third, 1 over e power I theta equal e power I theta all power minus 1, because it's a reciprocal, which is equal e power minus I theta. Fourth result, modulus of e power I theta equal e power I theta and e power I theta conjugate, which is further equal e power I theta into e power minus I theta, which is equal e power 0 equal to 1. Modulus of e power I theta equal to 1. Fifth one, e power I theta conjugate is equal e power minus I theta. Sixth one, e power plus or minus 2 pi I equal cos of plus or minus 2 pi plus I sin of plus or minus 2 pi, which is equal 1. Then you can say e power I of theta plus or minus 2 pi is equal e power I theta into e power plus or minus 2 pi I, which is equal e power I theta. That is e power plus or minus 2 pi I is equal to e power I theta. Now come to the basic things here. Look at here. Application in quantum mechanics. Quantum states, wave function in quantum mechanics are complex valued and are often expressed in polar form to represent their phase information. The polar form provides a convenient and elegant way to handle the complex valued quantities that are central to the mathematical framework of quantum mechanics. It establishes a deep connections between exponential functions and trigonometric functions with application in many areas of the physics and engineering. The polar form provides a convenient and elegant way to handle the complex valued quantities that are central to the mathematical framework of quantum mechanics. The beautiful Euler's equation is e power I pi plus 1 equal to 0. The Euler's identity, it's called Euler's identity, is an equality found in mathematics that has been compared to a Shakespearean sonnet and described as the most beautiful equation. It is special case of foundational equation in complex arithmetic called Euler's formula, which the late great physicist Richard Feynman called in his lecture Our Jewel. And the most remarkable formula in mathematics is Euler's identity. In the interview with BBC, Professor David Percy of the Institute of Mathematics and its Applications said Euler's identity was a real classic and you can do no better than that. It is simple to look at and yet incredibly profound. This comprises the five most important mathematical constants. Euler's identity is written in simple form e power I theta, e power I pi plus 1 equal to 0. Now let us understand this proof. I will look at here. E power I, suppose it's I alpha, instead of theta we are writing I alpha. E power I alpha equal to cos alpha plus I sin alpha. E power I, this theta, we put this alpha is pi, then it becomes e power I pi, where alpha comes, substitute pi, that is cos pi plus I sin pi. Cos pi equal to minus 1, sin pi equal to 0, both addition becomes minus 1, therefore e power I pi equal to 1. So far we discussed that mathematics of quantum mechanics in that Euler's formula and its polar form. We have done. Please subscribe our YouTube channel.